All right, good evening once again. Please, if you can hear me, kind of react to my message, my voice. All right, thank you. I want to welcome you all to this evening section, and without wasting much of our time, we are getting started right away. And please make sure you still go ahead and invite all your group members. Tell them we have started already. All right, today we are considering a topic and we have a wonderful facilitator in the house, which is going to take us through this topic. And the topic is database design and optimization. So, in our analytical extra mentorship session, we'll be having a fantastic database administrator to put us through this section. And without further ado, we have the person of Mr. Samuel in the house, wearing Guam, to take us this section this evening. Of course, we all know our ground rules in this section. We have to maintain punctuality. You have to come early to the class. Everyone must have an open mind. Of course, we are having a one class, and every one of us will participate in one way or the other. And I expect us, every one of us, to have a pen and paper with us right now. And please let's respect each other. Let's ask questions, no stupid question, no big question, no small question. You can ask your question during and after the session. If you have a question, you can put it in the chat or you raise up your hands. I will unmute your microphones. Now, who am I? My name is Kasali Samson. I am a business consultant. I work with one of the big four, EY Nigeria, and I'll be moderating this session today. I'm also a data analyst and I'm a website developer. And you guys can follow me up on my LinkedIn. I have my LinkedIn profile there. We can connect as data analysts. And right now, we are meeting our facilitator, Mr. Samuel, who is a data trainer. Meet Mr. Samuel, a highly motivated data professional driven by growth and equipped with extensive experience in diverse data roles and proficiency in complex data tools. His passion lies in utilizing data to tackle problems and collaborating with teams to deliver valuable outcomes, ultimately creating products that captivate users. His exceptional expertise has resulted in the development of remarkable data products and even secured an investor for a data-driven project in the past. Beyond his immersive accomplishments, Mr. Samuel is a seasoned data trainer and has successfully facilitated 10 consecutive cohorts of the Tech for Dev, the Women Textiles Bootcamp program, that is data science track, nurturing aspiring data enthusiasts and newbies along their path to excellence in the data field. Furthermore, with his growth plans and community dedication, he has formed partnership with various organizations, including the Lagos State government, to provide guidance and support to individuals embarking on their data journey. Having trained over 3,000 individuals from around the globe, Mr. Samuel impact is truly far-reaching. Wow, this is so. I don't know mouth word. I don't know. I don't know how to compliment, but this is a very good profile. We are going to be learning from someone that will take us by the hands and make us, every one of us, an expert. So without further ado, without me wasting much of our time, I want you all to join me as I welcome Mr. Samuel to the section. Can you just jam your hands? Just react, give him show your love, show your love. Mr. Samuel, you are welcome, sir. We have been waiting for you. You have the microphone now, sir. Thank you, sir. You're welcome.
All right. Hi everyone. Good evening, everyone. Good morning and good afternoon for persons who are joining from other regions. Thank you very much, Samson Kasali, for that amazing intro. I'm really excited to be here today, and I'm looking forward to an exciting session. Overall, I trust we're all doing great and all set for this session. So today we're going to be talking about database design and optimization. I think I'll have my screen shared. So I actually don't have much of a slide available for the session today, but I think I can make do with some basic aspects. Please let me know when my screen is up.
Your screen is up. We can see your screen. You can go
All
ahead,
right.
sir.
Awesome. Okay, so I have one of my slides here that I use for my sessions basically. And as Kasali has rightly said, my name is Samuel. Let me just put this. Think I'll just present this. So my name is Samuel Hagwam, and I am basically a data person. I like to think of myself as someone who has a bit of experience in keyword, please, a bit of experience, so that nobody drags me. So as someone who has a bit of experience in multiple data roles, being data science, tiny bit of data science, tiny bit of data analytics, tiny bit of um, data engineering, and also tiny bits of database management as well. Right. So I'm super excited to be here today. You may not know, but some of the contributions that I have made to some of the products in the world are some of the things that you get to use. So I currently work with Core Technologies, formerly Abzone Group, right, where we basically provide solutions for fintech organizations. So in a nutshell, we digitalize the way banking operations happen. So sometimes some of your banking operations might actually be on my desk for me to resolve, right, or to improve the performance of the database systems. So right, that being said, we can proceed. We don't actually need a whole lot of all of these. So we just basically need to get right into it. At this point, I believe everyone already understands what database is. We've been able to work with SQL a bit and understand some of those things. So let's proceed. So first off, let's understand or talk about it again. What exactly is a database? Let me see. Highlighted link below. Okay. Okay, so I still okay. Let's see. All right, that's fine. Okay, so let's get started. Let's talk about what a database is. What exactly is a database? As many of you know, a database is an organized collection of stored, structured information where you get to put your data and all of those, right? I like to think of database as something more simpler and also complex. How do I mean? For me, I like to liken database to banks, right? Our typical banks. So a whole lot of the things that happen in the bank is what happens in the database as well. Now, let's put it this way. First off, a database is a bank where you store data, right? So similar thing that happens in the bank happens in the in the database. For example, you need to go to the bank to deposit some amount of money. You do not just walk into the bank and then throw your money in the air and say, I want this money in my account before I leave here or before I get to my house. Nobody's going to take you serious, right? Basically, what happens is the bank has protocols, they have certain rules. You need to follow those rules. You need to do the right thing, pick up the deposit slip, put in your information in the proper format. Um, then once you're done with that, you take it to the person over the counter. In some cases, you have to queue, right? So you take it to the person over the counter, they look at it, all is good, they have it processed, and then your money gets credited into your account. Similarly, in the database, that's what happens. If you need to store data in the database, you need to follow certain procedures, certain protocols or rules that have been set. Now, if you don't follow those rules, you will not get your data stored. Now, you also need to get your money out from the bank. You cannot walk into the bank also and then maybe grab somebody by their neck and say, I want my money right now, or somebody is going to die. They'll basically they'll probably call the police on you, right? So you don't want to do that. Again, the bank has rules and protocols. you need to follow those protocols. You walk into the bank, pick up the withdrawal slip or form, and then you fill in the correct information, hand it to the person over the counter. They look at it, cross check it with what is on their end. Everything looks good, and then you get your money. Now, in cases where maybe you're trying to get um excess money from what is in your account, they tell you, oh, you cannot be able to have this because what you're requesting for is not sufficient in your account, right? When you make mistakes in maybe your name or so, or the amounts that you're trying to put in, or maybe your signature, right? They look at it and tell you, oh, this is not matching with what we have here, so you can't get your money, right? So you need to properly correct it before you can get your money. Similarly, all of these things happen in the database. For you to get a data that has been stored in a database, you need to follow the right rules. You need to write the right query, ensure that you're getting it from the right table, ensure that everything is properly checked. Also ensure that the data you're looking for is in that particular database or table. Otherwise, you will not get it, right? But when you follow all those rules, do everything rightly, you'll be able to get the data that has been stored in database. So typically, like I mentioned, your database can be likened to a bank. So we understand in English, we can be able to say a database is an organized collection of structured information or data that is typically stored electronically in a computer system. There are also more and more definitions about this, but I don't think that's why we're here. Right. Now, what we want to talk about is how exactly is a database designed and what exactly does it mean to optimize a database. Now, I currently work on the back end side. I think, let me see. Okay, so we'll talk about all of this later. I currently work on the back end side in my organization, which is the database side, right? Where we get to develop solutions, ensure that the database is well optimized, ensure that, oh, in case of cyber events or cyber attacks, the database stays secure at all times. In some recent months, I think about 2, 3 months ago, we had like a massive cyber attack, right? And then we had to ensure that the database stays strong. Before you just wake up in the morning and see that, my money is not in my bank account again. What's going on? Right? Basically, because the database has been tampered with or has malfunctioned. Right? So it needs to be secured at all times. Now, when you need to build a database, you don't just jump in and say, oh, I already know all the SQL statements, create database. So let's go on ahead and create our database, analytics extra. So let's do this analytics extra underscore um, Corpus workshop. Right. So you don't just go to your SQL environment and then say, oh, I already know how to create database, so let me just go and create it. Right. So many things have to come into play, and that is where database design comes in. So what exactly is database design, right? It's basically putting all the considerations of things that have to come into play before you can have a full-fledged database. We can actually say is the process or art of structuring the data. Let's put it as structuring and organizing. I hope I can spell organize. My village people should not organizing the data in the data database design is the art of structuring and organizing data to facilitate efficient data storage and retrieval. Yeah, and of course, security. That's very, very important. Security. Now, so many things come into play when you need to design your database. Like I mentioned, right? You don't just say, oh, because I already know the create database, I already know how to insert records, I know how to create a table. So let me go on ahead to create it. Now, in a typical business case, what you want to do is to go through certain steps. You need to go through certain processes, which I can actually say there are three major levels or stages of database design. Now, there are three major of them, right? I'm going to make it five for today's session. By five, I mean to say we're going to have one, which is requirement analysis. Two, we have conceptual. I hope I can spell conceptual design or stage. So let's just put it as stage. So three, we have logical design stage. Logical design stage. I think I just need to clear this off. Four, we have physical design stage. And then lastly, we have the, let's put it, implementation, test, and monitoring stage. Now, these five stages are what you need to do, right? Several things will come into play and we'll have them all in these five stages. However, the three major levels that we need to look at is the conceptual design stage, the logical design stage, and the physical design stage. Now, we'll talk about all of these guys, what they actually mean. When we talk about requirement analysis stage, this is the stage where you, of course, as a data analyst, first things first, before you go into any analysis, you need to first ask questions, right? Understand the business objectives and goals to achieve. Right. So before you go into any analysis, you need to first ask questions, right? What is the aim of this analysis? What do we aim to achieve at the end of the day? What are the problems that we're experiencing? What is the result that we're likely to get? Certain questions like that, right? So similarly, in database design, you also carry out your requirement analysis stage. Understand the business goal, understand what they want to achieve. Now, also understand certain things. Which database management system should we go for? Let me put it this way. So, under requirement analysis, I'll just requirement analysis. So, we'll be looking at understand business goal. So, let's look at understand the business first. Understand the business goal and why they need a database. Then also understand, oh, so we need a database. Then next, understand what DBMS to work with. Right. So whether you want to work with maybe a relational database or non-relational database, this is where you also need to understand, right? So you need to be able to carry out a requirement analysis that will now help you figure out how you're going to design your database. Now we'll get into some other aspects where you can be able to see, oh, this is what database design looks like. But then you need to understand the business first. If you don't understand the business, you will not be able to create anything. My manager says something all the time. A badly designed, let's say a badly or poorly, let's put poorly, a poorly designed database is a catastrophe. Catastrophe. I think I'll put myself in problem today with all these spellings. A poorly designed database is a catastrophe to the entire organization, not just applications. So in most cases, you have your database connected to an application, right? But in this case, a poorly designed database is not just catastrophic to that particular application. Its impact, whatever impact that happens to the database, right, would be felt by the entire organization. So that's how a database is. Databases are like power engines that carry the entire organization, right? In fact, the entire world, we have like billions, trillions, zillions of data, right? And where are they stored? Certainly in a database, right? So without a database, no organization can function as much as they should. Maybe for small businesses, of course, right? Let's leave that out. But then for larger businesses, they cannot function without a working database. Many organizations go as far as having multiple database. Fun fact, my organization, my typical day around databases is to work with over 1,000 databases. Over 1,000 databases. And all of these over 1,000 databases are not even my organizational database. They are external organizations, financial organizations that we get to manage their databases. So imagine something goes wrong with an external organization's database, and we are handling that on our end. It gets really, really crazy, right? So many things have to come into play when you want to design your database. You need to first understand the business, know what you want, know how much data will be coming in, and then you can now proceed into another stage. Now, the next stage that you're going to get into is the conceptualization stage. Now, this is the major first stage for designing your database. In this stage, this is where you get to start bringing up the ideas. Oh, I want to have 5 tables in my database. Now, those 5 tables are going to store this information, this other information, and this other information, right? So this is where you get to start creating that idea of the database. Now, like I said, you don't just because, oh, I know how to write SQL queries, or I know how to write data definition codes, and then you go and jump into creating your database. You end up doing a lot of bad work at the end of the day, especially if you're going to be building one for an application. So you need to ensure that you take your time, sit down properly, and craft out the idea. Now, in the conceptualization design stage, this is where you conceive the ideas. You start thinking, oh, I'm going to have 5 databases. Each of these 5 databases would have around 5 to 10 tables in them each. These are the information that are going to be stored in each database. So you need to start thinking about all of those things. What type of information does my business need? What type of restrictions would I need for this particular database, and all of those. Now, the end product of your conceptualization design stage is going to be a visual representation of what the database is going to look like. In most cases, this is where you get to do what is called your ERD. Now, your ERD is entity relationship diagram. So while you're conceiving the idea of how your database is going to look like, you start drawing them down. You create a diagram for it to map it. Oh, I want this particular table to connect to this other table. Now, if you look at my slides here, we'll be able to see the ERD. Not sure how to quickly put this out, but yeah, we'll be able to see something like this, which will basically show you relationships between one table and another table. For example, let's look at this. In the AdventureWorks database, we can be able to create an ELD to see how this particular database will be created. We want to create maybe 100 tables, right? So let's get all the 100 tables and create visual representations of those tables. I'm going to right click here and new database diagram. Okay, I need this. So let's see. Um, execute XP underscore. I hope I get this. Change the B owner to SA. Okay. Um, let's see if this works. Okay, so this worked. So let's see. All right, so we can create the database, right? the database diagram rather. Now here, this is an already existing database that we have here, AdventureWorks 2019. But then it has no ERD, so we can be able to manually create our ERD. Maybe you can try this later on your end. But then what we want to understand is before the database eventually gets created, we need to build the ERD ahead. This will help us be able to understand how one table will relate to another table. Now, remember, we're in the conceptualization design stage, which is where we get to think about all the possible things that can be for this particular database. Right. Now, in this stage, we can create the ERD. Just come here and shift and add, and then it's going to create the ERD for me. Now, in this case, what it's doing now is to create the ERD and show me how one table is connected to another table. So let's wait for it, give it a moment. Uh, let's see. Okay, so basically, we'll just give it some time to complete. Now, in a typical business case, right? Okay, so it's still in progress. In a typical business case, right? One of the things that you want to do will be to utilize an external tool for designing or drafting out how your database is going to be like. We have one of those tools like, give me a moment, let's see. Okay, so I'm just going to close. Right. So we don't need these guys. Just keep them here because they are not part of our major tables. Now you can see that we're basically not seeing it, but let me give me a moment. I will just zoom and keep it at 75 soon and keep that 50. Okay, so at 50, I can see all my tables. Now, basically what we have here is an entity relationship diagram of all the tables in the adventure works. So this is what you will be doing in the conceptualization stage. Define how one table is going to connect to another table. Now you're also going to be saying, oh, I'm going to have a table like this. This particular table is going to have certain this particular table is going to have certain columns like this, or I want this particular table to store information about the production location. For this, is going to store information like the name, the cost rate, the availability, and all of those, right? So when you're building this, these are some of the things that you'll be doing. Create an entity relationship diagram that would help you give a visual representation of all your tables. So you can see how each of them are connecting. Now, because this is an already existing database, in an organization, if you need to create one for your organization, right, or maybe for your work, you can check Lucid charts. So you can check Lucid charts, right? Lucid Chat would help you be able to create entity relationship diagrams for your database. You have all the tools that you need there, all the boxes, rectangles, shapes, and you can be able to use that to create entity relationships for your database. So in case you need to try something like this out, of course, you have something like this. You can be able to use it. Oh, this table would connect to this table using this particular key that we have here. So during your entity relationship diagrams, each of the boxes that you see also have meanings, right? For example, you see this particular one. Let's give it like a triangle. It basically shows you the key that is connecting these particular tables together. You'd also have your tables and all the columns that they are connecting with, right? So basically, in this particular one now, we can now see a visual representation of what our database is going to be like, and then we can now proceed into the logical phase. I believe we're all good. Can we all please confirm that we're all good? Maybe in the chat. Let's see that we're all good. Um, Okay. Getting into spellings. Oh, thank you very much. So I believe we're good. Awesome. Awesome. Okay. So we now have a entity relationship diagram. We can be able to see what it looks like for the Adventure Works database. So maybe in a situation where you get into an organization. So here's a tip, right? In a situation where you get into an organization and you need to work with their database and you're not familiar with it, first things first, request for a data dictionary, right? Request for a data dictionary, right? Now, if the organization says they do not have a data dictionary in place already, so what you need to do is to create an ELD for yourself. So if you work with SQL Server like this, you can be able to create an ELD for yourself. All you need to do, come here, expand the database, right click on the database diagram and create database diagram. In most cases, it will show you this particular error, right? So you just need to execute this stored procedure and change the DB owner to SA. But you may not be able to have that done in a standard workplace, right? Because you would not have permissions to execute a procedure or so, right? So in my organization, anyone who is not in the data team or data development team or DBA cannot execute any other command except for just select, 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 right? So you can't execute a stored procedure or any other thing, right? So you can be able to create one for yourself. I believe we have for this guy as well. Yep. Um, okay, so you can, I think I'll put this in the chat. Use KCC and have this done, and I can execute this execute, and then let's see, I can be able to create my diagram for this. Okay, so add. I was going to look at it, right? If there are already established relationships between these guys, it will create the diagram for me. And this is what I can now see, right? Now it tells me how one table connects to another table. In MySQL also, you can be able to do similar things. In Postgres as well, you might need a third party um, application like Lucid Chat to have that done, right? So it depends on whichever works for you. Now, when you hover your mouse, it tells you, oh, this is connecting to this particular guys using the other ID, the customer ID rather. Let's see. FK orders customers between customers and others. It also tells us here FK other product orders between the orders and the other products. And this as well. The foreign key is what is abbreviating as the FK, other products between the product and the other product table. Right. So we can be able to also check the data definition of the database and see how each of these tables were created. So when you have an ELD like this for yourself, you can then save it. You can just right click here and save the diagram for later use for yourself. Right. So that's about that for the conceptualization stage. Now, remember, like I said, in the conceptualization stage, you're able to create a visual representation of the tables that will be used for your database. Now, once you have that done, the next thing you do is the logical phase. Now, in the logical phase, this is where you then start writing all the queries that you need to write. Just clear this off. So in the logical phase, this is where you then start writing all the commands that you need to write and creating the actual database. So when you're creating the actual database, you're then attributing it. Of course, by attributes, we mean assigning it the proper columns. Now, when you're assigning the proper columns, so many things come into play. First off, we understand what a table is, right? I'll just go back to this slide. We understand what a table is. A table is made up of rows and columns, but then how about your columns? It's important to understand that your columns are defined by name, type, size, and constraint. So you cannot have a column without at least any of this. We'll take it again. Your columns are defined by name, the type, the size, and the constraint, which means that in your logical design stage, your columns, you have a table, create table, we're going to call it, let's see, what's today's date? October 6th. So create table October 6th. Let's call this. Um, so create table October 6th. And what we want to do is to create an ID, right? Let's call it participant ID. Right. Now, the first thing that we're doing here when we're creating our table, right, is to define the column names. So this means that your table has certain things that need to make it up. Now, those certain things that need to make it up are the columns. Now, your columns are also then defined by the name, which means the column needs to have a name. It then needs to have a data type. The column then needs to have a data type. Now, once the column has a data type, in some cases, right, the column needs to have, let's see, first name. Let's see, now, in some cases, the column also needs to have a size that will be defined as well. Now, by size, we mean define the size for that particular column. What is the amount of data that this particular column can be stored? Now, some of you now, basically for when you're creating your database, you just go ahead, create table name, column name, data type, column name, data type, comma, give it unique and some of those things. But then when you look at it, right, all of these things have concrete meanings during your database creation. So you need to ensure that you're looking into all of these when you're creating your database or the tables. I'm sure everyone also understands what the schema is, right? We'll come to that later on. So also your table, your columns are defined by the names, right? We have a column name here. We have a data type, which is variable character. We have a size for which it would take the number of data that has been specified. Now, the next thing also is to have constraints. So we need constraints for our columns. Constraints are very, very important. So in some columns, we might not put constraints. In other columns, they are of utmost primary key. And we want to have it as identity. Identity, we just put it one by one. So it's incremental by one data, right? So basically, your columns are defined by name of the column, data type, the size, and the constraint, right? Very, very important. We need to keep this in check, right? So in the logical phase, this is all what you get to do. You start building. For example, I have this here, which is basically for use today. Let's assume that we're create database for a bookstore. We'll call it library management DB. Right. Library management DB. And the next thing we want to do is to create the various tables, right? So having drawn or gotten our ERD, right, we'll then start creating our tables, define the name of the table, and then define all the columns for each of those tables. Also remember, your tables are entities, right? Hence why we have the entity relationship. Now, in the entity relationship, in your logical stage, you also then start saying, oh, I want to have a foreign key that would reference the books table. Where's the books table? So we have the books table here, and we have its own primary key, ISBN. So it is in your logical phase that you start defining all of these technically. You start writing it, how it's going to be. It is also in your logical phase that you then start saying, oh, I want to ensure that my database is normalized. By normalization, we mean to split your tables into multiple tables. For example, we have the KCC here that contains around like 4 tables. It contains 4 tables, right? Now, if this particular database were not to be normalized, let's quickly do something. Select all of, just drag this guy here. Um, let's do select all. Check this other one here. Of so do these from okay, so that's all. So now when we have this executed, right, it basically gives us all the records for these particular tables. Now we can be able to see that each table has its own data that it stores, which means that this database has been normalized. Now, if we decide to denormalize this database, we'll be having something like select all, just do this from customer, see, uh, join, let's see. Okay. So we'll just carry out like a tiny join for this. Oh, that customer ID, also see that customer ID joined. So products OP, OP, OP dots. Let's see. Sorry. ID equal to O dot other ID. So join. So we're just basically going to have like some kind of joins, right? So I can show you what it's going to look like if this particular table were not normalized. Then join, what's the last table, which is a products p dot cookie ID equals to, let's see, cookie ID. So we have other products. Okay, cool. So we have other products. Other products equals, sorry, equals to OP dot cookie ID as well. I'm just going to do something into the normalized table. So select all into the normalized table from let's see. Let's see. Okay, so we don't need actually need this. Select all. All right. So I can have this here into select all from this into the normalized table. Okay, so I'm trying to see what works for this particular guy. Select all from this into. Okay, so let me just do this. Select all from. Okay. All right. Okay, so this is much better. So we have this. Select all into these from. Select this. Let's just call this D. Right. Okay, so I'm not sure. Right. Still select all into this from. Okay, so I'm not sure why this guy is still returning this, but then column customer ID was specified multiple times for the Etsy. Hmm. Okay, so we basically need to list them out here. Okay, so I wanted to show us something, right? So we basically need to list them out here, and that will be taking quite a lot of time for us. Now, basically, if we decide to denormalize this particular table, right, we'll end up having a joint table like this, which will contain all the records in just one particular table, right? The only thing there is that we'll keep on having repeated information, just as you can see, lots and lots of repeated information, and it may not be great for you as an analyst to carry out your analysis, right? So you need to also, in your logical phase, define how you want to have your database tables. Do you want to have them normalized or denormalized? By normalizing them, we mean we want to split them into tables like this. By denormalizing them, we mean that at the end of the day, we just want to have a single table, sort of what we have here. Now, that single table is going to have every information like we have here, which may not be ideal or make the work easy for you during your operations. So, in your logical phase, right, so many things come into play, but then this is where you get to decide all the things that need to happen. You also get to look at your relationships, define your relationships that you want to have in your tables. For example, my mouse is freezing. For example, we have, let me close this guy here. For example, right, we have this particular one here, and then you get to decide, oh, what kind of relationships do I want to have? Do I want to have a one-to-one relationship where one record in one table has one record in the other table also? Do I want to have a one-to-many relationships or a many-to-many relationships? So you get to define all of those in your logical phase. Now, once you're done with your logical phase, the next thing that you want to do is to go into your physical phase, right, or physical stage. Now, in the physical stage, things that you get to look at are how to improve database performance, ensure that, oh, this database continues to perform well, ensure that it's scalable. By scalable, we mean it can be able to grow in size, in data, and all of those. We want to ensure that, oh, when somebody is trying to get a query, you're trying to run a simple query or maybe a simple select all from this, from a table, and then it's taking about 5 hours just to get select, right? So it's in your physical stage that you get to define all of those. Now, once you have all of those done, the next thing is implementation. You test that everything is all good, and then you keep on monitoring. This particular stage for monitoring is something that you get to do again and again and again. Now, once you've been able to design your database to the taste that it should be, the next thing is now to optimize the database. So what does optimization mean? Basically, when you're optimizing your database, it means that you're trying to improve the efficiency of the database operations. So database optimization is the process of improving the efficiency of database operations. There are a whole lot of things that also come into play, such as indexing, ensuring that your indexes are properly built for that particular table, ensuring that you have the right columns indexed so that it doesn't take time and the likes. You can also engage in caching or partitioning your tables. If you have large records in a table and it takes so much of time for the records in that particular table to get retrieved, then you want to have it partitioned, right? So you also need to look at whether you want to have a vertical partitioning or horizontal partitioning, and so many things. And like we've talked about the normalization and normalization, and then there's also query optimization, where you need to ensure that the queries you're writing are properly optimized. I also have like some few tips before we round up. I think I have some few tips during your so I think some time ago I contributed to this particular article, how you can write a basic SQL query to retrieve data. So when it comes to optimization, one of the things that you need to do as a data analyst is to understand when and how to use certain commands. When you're writing basic SQL queries, understanding the structure of the database and proper use of the right clauses should be duly prioritized. Start by understanding the DB structure. Like I said, if you don't have a data dictionary, you need to create an ARD for yourself, right? If you can. Now, once you have that understood, understand all the tables, what each of the tables mean, what type of data each of the tables hold, understand the columns, their data types, the constraints on those columns, the relationships between one table and another table. Once you have all of those things done, identify the specific tables and columns that are relevant to the data that you want to retrieve. Like I mentioned, get familiar with the data dictionary if available. Now, when you're writing your SQL queries, always have an idea of the results that you expect. If not, you will write your query, you will get a result, but it would be utmost rubbish, right? It would not make any sense. So ensure that you have an idea of the results that you expect, right? Also, utilize aliases for lengthy column names. It helps a whole lot of times. Utilize aliases when you're trying to retrieve your data. We'll talk about other things. When also not necessary to get all records, enable pagination by limiting the number of records returned and do not sort if it is not necessary. Now, what I mean is that instead of saying go to your database and let's do this. Let's just quickly look at this. So let me quickly look at this. Now, instead of looking at select all from the select all from the passing table, instead of doing this, right, if it is not necessary for you to get all the records here, optimize your query. Now, this is taking us about 1 second to complete. Is this 1 second? This is about 1 milliseconds to complete. Now, instead of returning all of these, if the only thing that you want to do is to check the column names here, then limit the number of records that you want to get. This will help you a whole lot of times. Now you can see that we no longer have that time here again because this is more optimized. So when not necessary to get all the records, please ensure that in your queries you utilize the top to get the number of records that you want. Maybe top 10, top 100, it gives you that in a very, very faster time compared to all. Now, also, when you're sorting, ensure that you only sort when it is necessary. Sorting consumes a whole lot of database resource. So ensure that you're sorting when necessary. If not, there's no need to now say, oh, order by, you want to order by last name and the likes, last name, ASC or so. So be sure that you're only sorting when it is necessary. Also, instead of retrieving all the records, right, you can utilize a where clause where the name is equal to this. That way, it helps to return your queries more faster. So you can optimize the queries that you're running and ensure that it takes smaller time to return the results for you compared to you just saying, oh, select all from this particular one, order by this and the likes. Again, where it is not necessary, I always advise write simpler codes. So if it is not necessary, please avoid these guys. Where it is not necessary for you, avoid joins, subqueries, and cities, right? If it is not necessary, there are cases where there's nothing you can do. You have to write a subquery, you have to write a join, right? Then you can, of course, give into that. But if you can be able to get your queries without making your code too complex, also ensure that you're looking into all of those. I believe with that, right, we've been able to cover for the most part of this. I think that's about that for this. Let's say, okay, so I think we've been able to cover for that. If you created your data dictionary or ERD rather, you can have it saved and then can be able to utilize it for your own use. I think that's about that for now, and I can take questions if there are any.
All right, thank you so much. Thank you so much, Mr. Samuel. Okay, so if we have any question, if any one of us have any question, can you please raise your hands up to take few questions, then I'll grant you access. So I'll be starting with Agbasu Marian. So please, you have the microphone now. Please ask your question.
Hi, good evening, Mr. Samuel. Thank you so much
Hi,
for
good
this
evening,
wonderful
Miriam.
session. Yes, sir. I really enjoyed it and I jotted a lot. But my question is, for example, as beginners or as intermediate or as someone who is looking for a job and probably you apply to a company that they do not have a database, like they do not have, maybe the only data they have is just maybe storing their files on Excel spreadsheets, and then they just need an analyst to help them like optimize their business, and then you want to advise them to create a database. Does it mean that, how am I going to go about it? Is the company going to, like what, while you were teaching, you said when you get to the company, try to ask someone to put you through. What if I get into a company that does not have a database? Am I going to create the database? Okay, I know I can create a database for them, but what is the advice that you're going to give to me? Is it to use my own system? Or is it for me to use my own SQL? Or how is it done in a normal working environment?
Hmm. Okay, thank you very much, Marianne. That's a fantastic question. So, in a working environment where you do not have an existing database, right, and then you need to create a database for them. So, you need to put into considerations the business perspectives, right? Like I said, carry out a requirement analysis. What is expected of you? What do they want you to achieve at the end of the day, right? Or what impact this would actually bring to the organization. Now, once you have all of those done, the next thing you want to do is to start drafting out your database. The session today basically is focused on database design, right? So you want to start drafting out your database, how it's going to look like, understand the number of tables that you want to bring in for that. Now, in some cases, the organization might have their data existing somewhere already in Excel. So what do? Do you create your database and then start writing it out? Oh, one eye is on Excel sheet, the other eye is on your SSMS. Absolutely no. You can be able to import your data from Excel into the database. So when you have that done, it creates. Let me share my screen real quick. Um, Okay, so I think my screen should be up. So for example, this superstore normalized, if you can see my screen, this is an Excel workbook. Everyone would be aware of the superstore, right? So this is an Excel workbook that was imported into this particular SSMS as a database. So you can also be able to do the same in an organization. All you simply need to do, create a database for it. Once you create a database, then you can go on ahead and import the data from Excel. Now that's for a case where they have their data as an Excel file, right? In a case where they have it as CSV, for example, let's quickly do something. We're not going to get practical, but let's quickly do something. Create a database. We'll call it import data from Excel or CSV, right? So once we have this done, we can refresh and we can right click, scroll down to tax, and we can import flat file for CSVs and text files. We can also import data for Excel files. So if we import a flat file or import data file, It's going to give us this screen. Let me see, just use this. So we'll have something like this, right? And then we can proceed, get the file that we want to bring in from our file manager, right? Your CSV file, put in the name, give it a table schema. Of course, we want the DBO, which is database object schema, and then we can proceed and import it into our SSMS as a database table. So once it gets imported, everything will become under the tables, right? That's for CSV. In a case for Excel file, you do similar thing, import data. When you import data, it gives you this import window. You choose your data source, which is Microsoft Excel. You get to select the file path, and then it takes you to the next one, which is data destination. And then you select maybe your OLEDB provider for SQL Server, and then have it done. And that way, you have easily brought in all the data from Excel into SQL Server. Then you now need to discuss with the organization how to have it connected so that any new data, instead of going to the Excel files, they are getting directly into the database, right? So that basically solves you a lot of problem from, oh, let's go and start writing, create table, insert into one record, two record, three record, and all of those, right? You easily have this here when you do that. So in an organization, they don't have a database. You need to create a database for them. First, understand what they actually want, understand the databases that they need. Do they actually need a database that would just be growing for them? Do they want it to be relational? By relational, whether it should have relationships between one table and another table, or they want it to just store data however it comes. So you need to understand those and understand database also has costs. So you need to also understand, oh, are you going to be working with Postgres for relational or SQL Server or MySQL, or you'll be working with MongoDB or any other one for non-relational, right? Once you understand all of those, you can then start creating your database, having drafted out the diagram. Oh, I'm going to have about 10 tables here. All these 10 tables, these are the type of information that they are going to store, and then it should be good. I have a friend who did some of those in an organization that he joined. There was no database when he joined, so he created a database for them from scratch. I hope that answered your question, Marianne.
Yes, sir, that answered it, but it's just remaining one tiny one.
Okay.
I'm saying, like, for example, if I'm going to be working remotely, does that mean that obviously they are not going to I'm not going to be using their PC. I'm going to be using my PC. So does that mean like my normal Postgres, because I use Postgres, so does that mean like my normal Postgres that I use is what I used to create it for them? So I'm having the company's data on my personal work system, or is it that the company has their own Postgres or something? Do they have their own database? I don't know how. I just want to understand that part.
I'm not sure I got your question correctly.
Okay, sir, you said I can create a database for the company. Now, I'm contracted as a data analyst and I'm going to be working remotely. Probably I've never even met these people before.
Mhm.
So the way you keep saying on the company's database, I feel probably the company has their own maybe SQL. Maybe just where I downloaded my Postgres, I downloaded it with my information. Maybe the company has their own. Are they going to give me the login to their own? Or I'm going to use mine? That's just the thing I want to know.
Oh, absolutely, absolutely. So, when you get into an organization as a data analyst, right, you cannot use yours. So, in the chat, I'm actually putting some things. There's development environment, developer or development environment. There's user acceptance testing environment, and there is the production environment. In an organization, right, you can only do your testings or maybe whatever you want to work on, your trial and error, you want to create a database, rough work, you want to do this, everything has to be done in the development environment, right? Once it gets through the development environment and has been confirmed as okay and good to go, then it goes through the user testing environment, which is where it gets tested to be sure that, oh, this is not going back into development, or it's all good. Now, once it gets all good here, it gets implemented into production environment. Now, in the production environment, there cannot be anyhow changes in the production environment. If maybe you missed out something in development or in user acceptance, and then you now decide that you want to go and make changes in development, it might just crash an entire application or so. And maybe I'll come and visit you in prison, or anywhere else, right? But I just know that when you try something like that, it's going to be a whole lot of problem. So in an organization, absolutely yes. If as a data analyst, right, you get into an organization, it depends on your role. For some organization, they only require you to get your data from prod environment or production environment, right? Whatever data you'll be getting will be from production environment for your analysis. Now, if you need to make changes as a data analyst, which will be very, very rare, if you need to make changes as a data analyst to a database, right, then you need to carry them out in the UAT or the development environment. Now, in those environments, you would have a lot of accesses. By access, we have the security aspect here, right? Which means, first off, when you get into an organization, you get your logins, you need to figure out, oh, I'm connecting to a database. What database am I connecting? Is this the correct server name? You need to figure all of those out. They'll provide you those information if available. But if not available, then maybe you need to start reading up about it to understand how it works. Now, once you understand, oh, the server name has been created, you then also need to understand what is going to be the correct authentication. Is it going to be Windows authentication, which means this is my own device, right? So once it recognizes that my signing is coming from this device, it will allow me connect. If it's a SQL server, it means that the organization will give you a login and maybe a password, which in most cases you have to change, right? Once you do that, then you can be able to log into the database environment, whether production or development or any other one, and then you can connect. Once you have it connected, then you should see a list of all databases. For example, this is my own personal test environment, right? For my sessions, and I just try to carry out some things. So you have like loads of databases that would be lined up here, whether in a test environment or UAT or production, right? And then, like I mentioned, in production, you cannot tamper with anything. You can only do that in development because, of course, anybody can work in development, right? But in production, you will not have access to do anything. The only thing you can do in production is to select, select, select. Now, also, in an organization, certain restrictions will be given, right? We have the aspect of um, grant and revoke, right, which will allow the organization or the database managers to be able to grant you access to a database or revoke your access from the database. So if there's an already existing database and some persons are already managing it, then they would need to grant you access, right, to that particular one. Once they grant you access, you'll be able to see your access in the logins. For example, I can decide to say, oh, let me create one without even writing any code. I'm just going to create one called, let's see, analytics, analytics extra. So I'm going to create a user called analytics extra, and then I'll give it a SQL server authentication and give it a password. And clear this 1234 at 1234. Okay, so 1234 at 1234. I'm going to do this. Enforce password policy, all of these are fine. And then I can come here to server rules, do whatever I need to do. Give this person maybe just public, right? Now, once I'm sure with that, I can then click on OK. By the time I click on OK, If I script this out, it's going to give me what I would have written, right? And then I can click on OK. Now, this means that if I share you this particular server name and this particular login with password, you should be able to connect to this particular environment. But because this is my own desktop, it's a Windows environment, so you'll not be able to connect it. Like I mentioned, this is what I would have written. Create login for Analytics Extra with password. I can simply come here and say this is it. Windows SQL Server Authentication login Analytics Extra, and then password 1234 at 1234. I can log in. Login failed for Analytics Extra. I'm not sure. Let me see. This. Okay, so not let me see. Let me see. Analytics Extra. Analytics Extra. Okay, let me try again. 1234 at 1234. See it. Okay. So I'm not sure. Okay, so I'm not sure why exactly it's failing, but then in an organization, right, you basically be able to log in with that particular username, and then it should work fine for you, right? And then you can then be able to see all the databases in that environment, and then you can start working with them, right? So I hope I answered that question as well.
Yes, sir. Thank you very much, sir.
All right, awesome, welcome. Hi, Victory.
All right, we'll be taking the last question by Victory. So, Victory, I'll enable your microphone so that you can ask your question now. Hi, Victory, please, you can speak. You have the microphone now.
Can you hear me? Good evening, everybody. Good evening, everybody. Please confirm you can hear me.
Hi, good evening. I can hear you. Please go ahead.
Okay. Thank you very much for this class. I really learned a lot of things that I actually didn't know before. Please, I'd like you to talk a little bit more about optimization. And I learned there are types of optimization. First optimization, second optimization, I think third up to fourth optimization. Could you please kindly just give me an idea of what it is, please? I know you already say
Okay.
optimization means,
Yeah, please go ahead.
yeah, optimization is trying to reduce redundancy, save time, and make sure your query run faster and all that. You're able
Yeah.
to break your tables into smaller tables. So, but I learned that there are types of optimization. So, please, could you kindly take me through that? Thank you.
Okay. So if I get you correctly, what you mean is normalization, not optimization. So optimization is basically improving efficiency, but normalization is basically trying to reduce redundancy. Right. There's the first normal
Yeah.
form, there's the second normal form, and there's the third normal form. Now, in most cases, in fact, majority of cases, you would most likely go for the third normal form, right? Which basically has all the relationships the same way that we currently have them. Now, the first normal form, what it basically does for you is that it removes repeated groups from your data or from your table, right? Basically, we have what is called atomicity in database, right? It basically just follows atomicity and ensures that every data that you have in that particular table are on their own, right? They are unique to each other. Now, your second normal form basically reduces redundancy. What it does is that it removes partial dependencies. It does not allow for a particular data to actually depend a whole lot on other columns or for other tables rather, right? And then we have the third normal form, which is the basic one that we have. It removes duplication. It ensures and enforces referential integrity and does everything that needs to be for the database. Of course, there's also 3.5 normal form and 4 as well, right? But like I mentioned, what you basically need in most cases, I'd say 99% of times, you want to work with the third normal form, which is basically what we get to work with.
Okay. All right. Thank you very much.
All
Thank you.
right, welcome.
Thank you very much for this.
I believe we're good. Okay.
All
I
right,
think that's
thank you so
about.
much, somewhere. I believe, does any other person have any question, or we are all clear? I want to believe we are very clear with those insights. Okay, I'll be picking the last person for today, which is Kolawole Lisomi. So you are the last person for today. So I will be giving you the microphone right away. You can ask your question. Thank you.
Yeah, thank you very much. The moderator, you say I'm the last person for today. Please, I'm not the last person. All right. So, thank you very much, sir, for today's section. My question is, I want to understand how like after creating a database now, I want to understand how we can actually deploy it on, let me say, maybe using AWS or using what's it called, Microsoft Azure or what's it called, Google Cloud. I really want to understand the deployment part of databases or data warehouse. So that's my question. That's my question.
Okay. So basically that's a lot of how would I put it? That's a lot of technical stuff. But yeah, one thing I'd like to first clarify is that you don't really deploy a database the way you deploy an application, right? A database is just there, except you basically meant a warehouse. Yeah, yes, absolutely. So, but for a database, you don't really deploy it the same way you deploy an application. Instead, the thing there is that your applications rely on your database for functionality. Your applications rely on your database for functionality, right? So instead, you deploy the application. In the process of deploying the application, you ensure that your database is all up and running, right? If you deploy an application where your database is having issues, then that's basically going to be a lot of grass goes for you at the end of the day, right? So yeah, you deploy your database basically when you're moving into a cloud environment, maybe in AWS or in Microsoft Azure, right? To the best of my knowledge, Microsoft Azure provides you like a whole lot of services, and it depends on your, how would I put it, on your subscription with Microsoft or Azure, right? But then Microsoft a whole lot of times gives you that opportunity or option to handle your operations themselves, right? So they get to do all those deployments themselves, ensure that whether you're looking at serverless or on a server, they get to handle all of those for you and then have it properly deployed, right? So in my organizations, because what we get to deal with are too sensitive, in most cases, Microsoft handles most of those for us, right? What we just do on our end is to ensure that we are managing all the database operations. Oh, someone is writing a query from a particular table. For example, from a particular table, someone is trying to insert data into a particular table, and at the same time, someone somewhere else is also trying to extract data from that particular table. And at the same time, someone else somewhere is also trying to update or delete from that particular table. There's something called lock, right? SQL would eventually lock down that particular table for those operations to wait for each other to process. So what we get to do is to then look at it, oh, this particular query or maybe this particular table is not properly optimized. And then we can now look, oh, what is the indexes for this particular table? How can we be able to sort it? Maybe the statistics of the table is bad or the indexes, or maybe it has a high fragmentation, then you start looking at all of those things to have it properly sorted. Or maybe because we need to set the isolation level, isolate one transaction from another transaction without actually making them an actual transaction statement or command, right? Then we are able to look into all of those things. But to the best of my knowledge, in my organization, basically all our database deployments are usually handled by Microsoft. So yeah, but of course for AWS, there may be some other processes also, but I do not think you need to deploy a database the same way you deploy an application, right? So, yep, I hope that answered your question.
Yeah. Thank you very much.
All right, all right. Okay, thank you very much, everyone. It's been super exciting getting to be here. Do connect with me on LinkedIn, and I'll also connect back. And I'm hoping that everyone gets to commit into their work, do amazing, and get to make impact for yourself or whatever organization that you get to um, get in touch with. So thank you very much, everyone, and I'm rooting for everyone to learn data rules and also avoid the current ongoing SAPA slaughter. So yeah, thank you very much.
Thank you so much, Mr. Samuel. Can we just all give it up for Mr. Samuel for this evening? He has given us a lot of information. Just react and just clap for him. This is so inciting and insightful. And we promise that we are going to implement everything you've taught us today. Thank you so much. We want to appreciate the fact that you are around this evening. And so, guys, we have come to an end. We have come to the end of today's section. Once again, on behalf of everybody, we want to say thank you. And thank you also to Mr. Adewale Yusuf for giving us this opportunity to also learn on this career. So I will have to say a goodbye and a good night to every one of us. Thank you so much once again, Mr. Samuel. Good night, everybody.
Bye, everyone. Thank you very much.